First of all, we would like to talk about how gas chromatography works before going into the details of the flame ionization detector. In gas chromatography, a gaseous mobile phase transports gaseous solids through a column as the one shown in the picture. As we can see in the diagram, the sample is injected before entering the oven and column. In order to move the sample through the column, we need an inert gas that serves us as a carrier. After leaving the column, it is that the solids flow through the flame ionization detector. In order for this process to work, the capillary column must be at an adequate temperature to produce enough vapor pressure for the solids to be eluted reasonably. Then, the detector will be at a higher temperature so we can make sure that all the solids are in the gaseous state. For gas chromatography, the size of the sample must be very small since the column just can handle very small volumes. The sample can be introduced into the process by using a syringe or a gas sampling valve. Now, let's talk more in detail about the functions of a flame ionization detector. A flame ionization detector is used to detect the ions produced by a flame. In order to be able to detect these ions, we need two electrodes, which are used and the potential difference is applied. This diagram shows the different steps through which the eluent gas coming out of the column goes through. As shown by the pink section of the diagram, the eluent from the column enters the detector. At this time, hydrogen is mixed with the eluent so that it can go to a small jet where it is burned. This reaction shows what happens. Carbon atoms produce CH radicals which produce CHO plus ions in the flame. At the bottom of the flame, we have the negative electrode. In the area where the collection occurs, we have the positive electrode. High voltage is applied between the electrodes so that the ions produced in the flame can be collected. As shown in the diagram, in order for the detector to work properly, we need three different gas inlets. Through these three different gas inlets, the gases that are normally used are hydrogen for the combustion process, nitrogen for the carrier gas, and air or oxygen to act as the combustion agents. Now, let's switch gears a little and let's talk about the advantages and disadvantages of using a flame ionization detector. There are many different advantages when using a flame ionization detector. First of all, flame ionization detectors are very sensitive to a wide range of components. Not only that, but it also works over a wide range of concentrations. A really good example of a flame ionization detector is the Autofilm Flame Ionization Detector, manufactured by AFC International Inc. This specific detector has a range of from 0 to 10,000 parts per million, and the detection limit is of 0.1 parts per million, which is pretty low, which is a really good detection limit for a gas chromatographer detector. By far, the flame ionization detector is the most useful gas chromatography detector. It is also the most commonly used in gas chromatography analysis. Now, let's compare two different detectors, the flame ionization detector and the thermal conductivity detector. Which of these two detectors is better? The flame ionization detector or the thermal conductivity detector? And yes, the answer is the flame ionization detector. And this is because the flame ionization detector has a much lower detection limit than the thermal conductivity detector. Now, let me clarify something. By better, we mean that it has a much lower detection limit for hydrocarbons than the detector that we have described previously in this presentation. Now let's talk about the disadvantages. One of the disadvantages is that the sample use is destroyed since it is burned by the flame. However, it does not matter much that it's destructive since the detector requires only a minimal volumes of sample. Another disadvantage is that the flame ionization detector is non-selective, so there is a potential for other compounds to interfere with this analysis. One last thing is that this detector responds to most hydrocarbons, but it's insensitive to non-hydrocarbons such as hydrogen gas, helium, nitrogen gas, oxygen, carbon monoxide, carbon dioxide, water, ammonia, nitric oxide, and hydrogen sulfide. Although these disadvantages exist, the flame ionization detector is still one of the best detection methods in gas chromatography.